Hi, pool guy. I've got an older Pentair Minimax 75 on my spa. Works great, no functional problems, but it just started making a rattling noise when water is flowing through it. Sounds like it's coming from the manifold area. Makes no difference whether the heater is off or on, simply having water flow through it makes the noise happen. It happens from the minute the water flow starts until it stops. Turning the jets on increases the speed of the rattle. Letting it fall back to normal circulation decreases the speed. I own a stethoscope with a probe. I can't hear any difference when I probe various areas of the manifold. They all sound the same. Seems like there's something loose in the water flow. I looked at the parts diagram. The only thing I could see that could come loose is the flow valve.
And the bypass.
I took it out, looked at it, and it looked like the hole in the plastic plunger was no longer round, like it had worn. So I thought perhaps the rod in it was rattling around in operation. Bought a new one, replaced the entire assembly. No change. May actually be slightly louder. The pressure sensor, not shown in the diagram but screwed into the manifold on the left side, looks okay, nothing broken. I took the manifold off and looked and can't see anything loose in it. There's no buildup of anything there or in the heat exchanger tubes. One of the heat exchanger tubes, the center one, has deteriorated to the point where the copper was gone except for a small piece at the bottom. I added a layer of RTV to it along with the gasket that was there when I put it back together, but no change. You have a few videos addressing this. It discusses the water boiling, but my rattle happens with the heat off. Discusses a similar sounding problem, but theirs went away when the heater was off, mine doesn't. You mention a thermal regulator problem. I can't see such a part in the breakdown on mine. You also mentioned scale buildup. I bought the heater used, so I have no idea of its history, but I doubt it's ever been descaled. How does scale buildup cause a rattling sound? When I had the manifold off, I looked in the tubes of the heat exchanger with a flashlight and could see nothing but copper down the tubes. The heater is old, but it was not used for many years until recently. I can descale it just because, but doing that is going to mean I will need to buy a second flange assembly to attach the fittings to, and I'd rather not cut the PVC off it, which is what would be needed to attach fittings to run a descaling pump through it. Thought I'd ask this question before going through all that.
Okay, this is actually a kind of a fascinating question, and I would have clearly said if it happened when it was running that it's a scaling problem. So I want to answer that part of the question because they asked this part, they asked that specifically. What happens in the inside of a heater if your chemistry is off and you have certain circumstances that happen is you get a scale buildup on the inside of those tubes. So as water flows through, flame comes up through the tube, up from the burner tray through the heat exchanger. The system is heating up, but because there's a scaling on the inside of the tube, the water's not collecting the heat off. And when it's not collecting the heat off, those tubes start overheating, and when they overheat, it starts to rattle and chatter. That's when it's running. So that answers that question is what happens is there's so much heat in there, the heat exchanger can only handle so much before it literally starts to flex and move. And that's why a heater has a redundant high limit switch, or it has a high limit switch and a redundant, because if the heat gets too high, it needs to shut off. In this case, if you can't see anything built up in the exchanger itself, do not waste the time, spend the time, worry about descaling it. First off. If it happens no matter what, you have to look at some other things. Through the exchanger, only so much water goes through the exchanger. People really think that a pipe goes in, pipe comes out. They think all the water goes into the heater, goes through all those little tubes, and all collects, come back, and goes out. And the fact is, that's not true. Only a small percentage of the water, while all of it's going into the heater, only a small percentage of it goes through those tubes and gets heated and comes out. Most of it goes through a pressure bypass. Sounds like you replaced that already. if there's chatter, to me, at this point, without knowing any more, is you're trying to force too much water through that heater. And the bypass can't handle it and it's vibrating. And that's probably why you started seeing some elongating and changing. What I would recommend doing is a heater bypass. So it's going to require some cutting and some plumbing, because what you didn't tell me was what kind of pump was on there, what type of flow was on there, what type of anything. All you told me was you have this little, I would call it a little heater, because it's a 75,000 BTU heater, which is a pretty small heater, and who knows what you're trying to push through it. Well, if you're trying to push too much through it, the pressure buildup in there is going to create all kinds of stuff. What I would do is I would cut your plumbing, put a T on, put a ball valve and T after your heater, and adjust it.
After or before?
So one before, one after the heater. So it comes out of the filter, part of the water goes into the heater, part of the water bypasses through this now cut in bypass thing. Because realize, again, most people think more water through the heater better. No. The actual amount of heater that goes through the heat exchanger is only about 15 or 20% of the water that you even put into the heater. Now, if you're trying to overplow water into the heater, you're now forcing too much water through the exchanger and too much through the heater. So a bypass might solve all of this, and we're literally talking about $25 worth of parts here and a little bit of effort of, before you go in the heater, tee it off, put a ball valve or gate valve, whatever you can find or use, and then after it comes out of the heater, tee it all together, so that part of the water, as it comes out of the filter and heads toward the heater, part can go in the heater, part can go through that bypass, and then you can adjust that. And you adjust it so that you're getting enough into the heater, but you might, depending on the size of your pump, you might need to bypass most of it out. And what that will do is that'll take some of that pressure off, and it won't force that bypass to just get pounded all the time, which might be creating and is likely called, there's nothing else in there unless you have a freaking marble or a golf ball inside there. There's nothing else other than that. It probably has a spring on it, and it might have what looks like a car thermostat on the end. And that thing is just being pounded. And no matter what you're doing, it's trying to pound open, but the spring is pushing it shut. So you're getting this kind of cavitating in there. That's the only thing other than an overheating exchanger that's going to cause that sound. Bypass it, throttle it halfway, try to send more water through the heater than not through the heater, and then open and close that until you can mitigate that sound. And I would bet that will make the sound go away.
As an ancillary question, as people replace single speed...
Are you still on?
I am still
okay.
recording.
Okay.
As people start replacing a single speed pump with the required variable speed, because the government tells us we can't sell them anymore,
right.
Do you think people might experience this more?
I think it's definitely going to change things, because variable speed, if... This is actually a great point and a great question, something that we're going to have to deal with. So a variable speed pump starts out at a half a horse or a quarter horse and ramps up to a horse and a half. Or it starts at a half horse and ramps up to 3 horse, depending on which one you pick. Think about all the variable speeds, and no one knows the difference. One costs them $1,200, one costs them $2,000. They buy the $1,200 pump and it's way undersized, or they buy the $2,000 pump and it's way oversized. What happens is you're jamming all that water into the heater, especially as you're ramped up in speed, and you're creating this issue. Or they go, oh, I only want to run it at 400 RPMs, which now it's like trickling water through. They wonder why the heater won't fire, or the heater fires. Then it overheats because it doesn't have enough water, and it goes bam, 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 and shuts off, and they don't have any idea. They think it has nothing to do with the pump. Well, that heater, you might activate the flow switch, which turns the heater on, but there's such a minimal amount of water running through it that it's not drawing the heat away from the exchanger, and next thing you know, the thing's hammering because there's not enough water. So you need to ramp it up a little bit. People don't think that the heater has anything to do with the pump. Well, it does. So if you have that perfect storm where just enough water shuts that flow switch, kicks the heater on, not enough water there, you're literally boiling the water that's running through because it's not running fast enough. It's definitely an issue that's coming. Definitely. And 80% of the builders out there don't build bypasses. We, however, have always built a bypass in. So no matter what, you look at any one of our systems, we have an additional valve or two to throttle the water so that we can send, because we're always looking for maximum flow. Think about what we build when we have waterfalls, when we have water features, we have spa spillovers, we have all these things working. We want to maximize the amount of water getting back to the pool. So we know only some of it's going into the heater. Most is bypassing anyway. So let's bypass it before it gets there. And then let that warm water meet with our bypass and go back to the pool. So we're in our company is in a perfect scenario with all this happening because we pre-built into it. 80% of the companies out there never imagined that they would have a pump that went from a half horse to a horse and a half. They built the whole thing around a 1 horsepower pump. If they even thought about it, let alone did the work to figure out the calculations to how it works. So yeah, as time moves on, and now you can buy a straight 1 horse speed pump currently, but as soon as you go up to a horse and a half, it's now a variable speed. Well, variable speed doesn't mean anything to someone who has no idea what that means. The RPMs, how much water is flowing through it, how much is going through the system, as much as the government has tried to save electricity by doing that, they created, unfortunately, the term is a shitstorm of how the systems work. And until you and I go out to the field and go, well, clearly we need to put a bypass on this because now this 3 horsepower pump, when it's at maximum speed, and a half horsepower variable speed pump is probably still pushing more water than most of the original 1 horsepower pumps, and the system was only designed for a 3/4 horsepower pump.
So
someone's got to do all that.
Is it
it's got to do that.
The heater, but it's also affecting
all of it.
The filter,
the efficiency. So here's the funny thing about our government. They say, but we need to be energy efficient. So they create this desire to need to have 2-speed pumps and variable speed pumps and everything, and yet most of the pools are built with undersized plumbing, which is all about efficiency. Now you put this crazy motor on there that has no idea what's on the other end, and now you try to cram more water through it, which it's resisting the whole way, and the whole system screaming, saying stop, 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 and yet the energy efficient government is telling you to push more in, and you create this shitstorm of stuff that just doesn't work. It's not designed that way. And so just because a politician thinks that, yes, this is a great idea, it doesn't translate into what's currently on the ground.
And it doesn't.
And we don't have a choice but to put that stupid thing on there because they outlawed everything else.
And you can't switch like for like anymore.
You can't.
Because they outlawed the old ones.
Yeah, and not only that, most of us, not me and you, but most of us don't understand that. So instead we go, oh, okay, we'll put this one, because guess what? We make more money when we sell them this one, and we put it on there, and it's 1,000 times less efficient because they're pushing the speed too high, and they're pushing it through things that aren't designed to have that water push through, and now they're spending more money on electricity, not less. You made more money, and you think you're a hero because now you're rich, and yet you screwed the whole system.
Anyway,
just like he says.
Also,
so there we go.
Don't mind the mess, but also Tango back here, our umbrella, Goffin's cockatoo. The more riled up Al gets about this topic,
the more he gets.
The more riled Tango gets. So we should tell our government to stop riling up our poor Tango.
It's kind of crazy how real and true that is. that
Yeah.
it's just a backward system. Somewhere along the way, someone lobbied for all of this change, but the change doesn't translate into the real world at all.
The
Not
hundreds
at
of thousands
all.
of existing
Dude, the
pools.
millions of pools that are out there,
Yeah.
this change basically negates them, and unless you spend a ton of money to reconfigure all of that, we end up in this weird position that we find ourselves now, and we're going to hear moving forward a lot of thumping heaters, a lot of flow problems, a lot of people screaming because the pressures in their tanks are different and they don't understand what it means.
Hi, Tango. And it
and
just
that's
it
it.
upsets Tango.
And it upsets Tango. So there we go.